Wait to get live. Let's stream. All right. I think we are live. We should be streaming, I suppose, on LinkedIn and Twitch and YouTube as well. So let's get started. All right. So, okay, this is Jensen Huang. For people, I think he's quite famous. And he just got famous for saying we shouldn't, I mean, going forward, kids should not learn how to code. And LLMs and human level languages are going to be that good that we would just be able to tell it what we need and it would do whatever it needs to do. Um, I mean, I'm probably a little biased here, but I would see it when we believe it. But even if that happens, we still need to know how the underlying systems work. So you should absolutely learn how to code, because learning to code is not just to solve a problem, but it's to give it a set of skills to critically reason about things. How do you break it down into steps, and how to solve those problems? But that said, let's ignore his advice and learn how to code, actually. So the thing that I wanted to talk about today was I had a very interesting discussion about the developer experience around Prisma, right? So how the ORM library works, where you just have it kind of like figure out your table structure, and it gives you a bunch of like methods where you can query on it and so on and so forth, and also with Drizzle, right? Drizzle ORM. Now, Drizzle ORM is another one which kind of like talks about how it's kind of like a query builder of sorts. So let me see if I can grab some code samples here. Yeah, so it basically has like db.select.from countries.left join and things like that. So it kind of has access to your table structure, and it provides sort of like a what do you call it, like a fluent interface for doing this. So it's like SQL like libraries that are there, but then it works in TypeScript, so you can have type checking and so on and so forth. Now, this is basically the object impedance mismatch that we're talking about, right? Let me find out. Object impedance mismatch. So the object impedance mismatch is basically, or object relational impedance mismatch is basically it's like a pretty old problem, right? Which talks about, yes, you have all these programming languages that are object oriented, and then you have all these things, but then your SQL is basically a relational language, right? And anytime you try to, work with one with the other, then you're going to have these problems where you cannot quite express all the ideas in relational languages or relational sort of like an algebra in object-oriented language. Neither can you take all of the object-oriented concepts and port it to the relational algebra. They're just two different worlds, right, to do this. Now, maybe specific points around this are probably not relevant, but the idea is this, right? So in a relational model, you have relations, and you have the tables, and then you have the relationships between tables. Or tables are also called relations in RDBMS and things like that. And then you have a way to do filtering and projections, and you can seamlessly kind of like mix columns from one relation with the columns in another relation, and then you can do various things with it, right? And SQL is extremely powerful. I mean, I feel it's one of those beautiful languages that got created, but then there isn't a whole lot of integration on the programming side. I think Link is probably the closest we got to in sort of like language integrated queries that's there. I used to work for SAP, where ABAP had the first class support for queries. So there have been a few exceptions in this category, but again here you see they kind of like invert, say, from score and scores where score is this, and then they select score and all. It's not quite this. So, and then there's a lot of like shenanigans around like data sources and things like that where you have to deal with to do this. So those are all interesting concepts. But what I really like is to keep SQL to in SQL. SQL is fine, it works very well, but then use this pattern called CQRS, which is command query responsibility segregation, right? So CQRS basically talks about, first you have these queries and your application model, and then you have commands that you send to it. So there is this query model and there's this command model, and then you have, it basically reads it from the database. So in this particular model, we basically are not going to replicate the entire model that's there, like sort of like an active record or an object relational mapper or things like that. We're going to let our queries be queries, and then have the table structures that, or the return values that are there kind of like map onto the structures that are here. Similarly, on the command side, we're going to have like higher level business logic that is there. And then whatever changes you need to do to the database, they would go in as insert statements or update statements or what have you within a transaction. So we are essentially eliminating the need for a sort of a ORM layer by having these separate things. And again, these are all guidelines, more like, and rather than doing this. And the reason why I like CQRS patterns is that CQRS works really well with domain-driven design. So I'm a huge fan of like domain-driven design and the ideas of bounded context and things like that, and so on and so forth. This naturally lends itself. So once you're thinking in terms of domains and thinking in terms of domain models, and the ability to read a model from it, and then doing all these things, it works very well with the abstractions of like domain-driven design and so on and so forth. And by the way, this Martin Fowler Blicky article is an amazing sort of like example into this. So that's one of the reasons why I like SQLX really well. So SQLX is this Rust library, so I absolutely love this library that's there. And what it does is this. So let me see if I can get to its GitHub page to show what it looks like. And this is what we're going to be working with. So SQLX is, I believe, the right level of abstraction where you can give it queries. So let me see if I can pull up some examples like here. Yeah, so here we say select star from users, and then you can do this. So let's see if I can show a from row implementation here. This is SQLX is not an ORM, which is in fact a feature, not a bug. So what it has is, so maybe I can show it in terms of an example here. So let's do that. Let's jump into code. It's often easier. So let's say so I'm going to call this a query mapper cargo new. Let's call it query mapper. Right, so in fact, it's a binary app, but yeah, I'll change it to a library later. But the query mapper. So let's do this. So let's add a bunch of libraries that I know we'll need. Cargo add Tokyo SQLX. I think that's good to start with. So SQLX comes with certain features. So I'm going to use Tokyo. So I'm going to basically enable that it's going to use Tokyo. So if you say cargo, what features Tokyo, and I'm going to use I'm going to use sorry, wanted SQLX. Okay, this is not the features that I was looking for. So I'm going to use runtime Tokyo Rust TLS. That's there. Maybe I'll add Chrono later, but we'll talk about Chrono and other types later. But at the minimum, I want this to be in there. So let me add those things. And I also want support for macros. I think it's enabled by default, so that's cool. So we'll just get this. So Vim, I will use cargo toml, and let's add. So here we'll just say we'll get the full here, and we'll get let's say I want a Postgres, and then I want the Tokyo runtime Tokyo. I'm going to use the Rust TLS packet for this. So that's there. Like main.rs. I will basically make sure that this is a Tokyo main. And I have a database with me. So let me talk about the database a little bit. So this is the OMDB database. So let me talk about OMDB. So OMDB is the Open Movie database. So I actually just use the dataset that's there. Let me see. OMDB is the API, but we can actually get the dataset too. Yeah, it's the Open Media database, and I basically downloaded the data from here. That's there. Yeah, I think I got it from one of these. Yeah, I think it's in the public domain. I set up this data set that's there. And so that is my OMDB data set. So it has a bunch of like jobs and casts and movies and people and things like that. So I use this database to kind of like explore what Postgres has. And I mean, it has all of these, tables and references, everything set up. So I'm just going to use this as our example to explore, because most of the times I'm just going to do a lot of these queries. And then we'll also talk about, okay, how do you do inserts and updates and things like that. So let's deal with this. So I am going to make sure this runs first. Oh, this needs to be async. I guess it works. So cargo run, everything should compile. This is just to kind of check that my toolchain is still working. It's not broken. And we get hello world at the end. All right, so now let's connect to this database and then see how that works. So we'll say let pool equals pg pool options. Probably I need pg pool options. Yeah, this is pretty much what we need. So we have the max connections, we have the connect here. Okay, this looks good. So OMDB, let's connect to that. One of these days I'll learn how to type. Let's import this. Right, so this is good. And now we'll say SQLX query as. So there it has two things. So you can do a query and query as. So let's see if I have a struct for the movie, and I'll call it movie, and I'll say I want the ID. I think it's an I64. It's a big int, I suppose. I'll set it. I'll figure it out. Then I have the title, and I probably should look at the OMDB structure. Please equal the OMDB movies. Yeah, ID, name, and date. And ID is a big int. So I'm just going to take these three for now. I'll worry about the relationships later, but then just these three, and then see how I can do this. So this is what the table looks like. It says select ID, name, date from movies, limit 5, order by date, descending. So basically find out. Let's see. I should probably put limit 5 after. So let's see what this gives us. So this basically gives us, this is interesting. So the date is null. We'll also say where is not. Right, so yeah, some of these it's like 2027. That's interesting. But yeah, it gets some of this. Maybe if I do ascending, yeah, it gets some of these older movies which are clearly 1890. Seems something wrong. But Anyway, maybe they are, but maybe they are really old, like motion pictures and not really movies. But anyway, so you get the idea. So you have this. So let me try to map this struct, and I'll show you what is happening here. Name, and then we'll have the date. And this, I mean, this is where we need to make a choice what it needs to be. So I'm going to add chrono, cargo add chrono to the project. And I'm also going to cargo toml and enable chrono for SQLX. Now, chrono is one of those libraries that's similar to like Joda time in Java or something like that, which will give you this thing. So I'm going to call it chrono naive date, right? So this is I can't believe that Copilot is making these mistakes. So I have this struct that's there, and I'm going to map this onto this. So I'm going to say let SQLX query as query as bang, and I'm going to say, let's see, select movies. No, I wouldn't say select star from movies. I just want to do select ID, comma name, comma a date from movies. I'm going to do a fetch all. That's not what I want. I'll do a fetch one, and leave this this way, and then say let movie equals. I'm also going to do a limit one, just so it's there. So right, so this is there. So I'm going to do this. Now it's going to give me a bunch of errors. So let me show this. So it says database set database URL to use query macros online, or use cargo SQLX prepare. It's kind of like breaking up. So let me kind of move this over. So it says use query macros online, or run cargo SQLX prepare to update the query cache. Right, this is what it does. So right now, the way this works is that this is going to inspect the query at build time, that is at compile time, and it's going to create this mapper. So I'm going to quit Vim for a sec. I'm going to .envrc. There's no such file, so I'm going to say vim.envrc. I should have just opened it there. So export database URL. This is clearly some example code from Udacity. Yeah. So let's see. Di slash, that works. No, it doesn't see it as a surround. D slash db, that should work. I'm going to dir allow this, and I'm going to start Vim now, so that when Rust Analyzer starts, it's able to pick this up. Right, so I could have also done this and LSP restart, but yeah, I was just being lazy. So now if you see here, now it's able to compile this. Okay, hopefully. Let's see if Rust Analyzer catch. Yeah, so it's able to compile this, and it's able to find that the type for this is actually a movie, right? Because this is what I have. I'm going to say println, and I'm going to say this is the movie that it looks for. And what I'm going to do, yeah, so it says it doesn't implement debug, so let's derive debug for this, right? And this should be fine. Now, so now there are errors. So let's look at what the errors are. It says the trade bound string from option string is not satisfied. And then it says trade bound naive date is not satisfied. So that's because if you look here and the definition of movies, ID is the only thing that cannot be null. Everything else can be null. So the name and date are null. So it's asking us to implement that. So essentially, if I do an option of this and an option of this should be good. Right, so this should be good, and I should have this. So now this is a bunch of warnings that this is not being used. So this is okay. So now let's run this and see what happens. So let's do a cargo run this. getting chrono. It's building all the stuff. Yeah, so it basically returned this movie. So it has some aerial, some date, blah, blah, blah. So this works. Now, this is not the interesting bit. The interesting bit is how does it know that this is sort of like, you know, what's the query that this runs? So this is what we want to look at, right? So what is this macro doing this? So if you expand the macro, so I have this, so in case you're interested, I have my whole NeoVim repo where you can, kind of figure out what my configurations are, but this is what it is. So what it does is that it actually tries to build this. So let's make this. So it's trying to create these query arguments, and it's basically just default. There's nothing here. And then it's doing a query with actually method. We'll figure out what this method has, and it has these arguments. And it also has a try map here, which has this thing. And this is what is there as the query. So the try map is one. So let's look at some of the documentation for this to understand how this works. So there's a SQL query with, and there's this try map. And here it somehow tries to reflect on the structure of this query. And then it tries to, generate, basically takes the row, and then it tries to get a try get unchecked on this as I64 and option of string and this thing. I believe it's interesting how it kind of picks these types. I would suppose it's picking these types based on the types that we are setting for the struct, and basically just adding it. Probably it's just doing some validation around should it be an option of a string. Maybe it has the type info and then kind of like checks if it's valid or not. I don't know. But yeah, we'll find out. We'll find out what all this is. But my idea is that instead of writing all this boilerplate, I want to have a method that would be a query mapper like this. So say, for example, if I have a movie query as a struct, and I basically want to have a derive on, say, a query mapper here, and I want to also say SQLX or SQL of ID name. Yeah, so pretty much this, right, from the movie. And I want this to generate the following stuff. Right, so struct movie query result, and this would be this would essentially be this, right? So I want this to be generated, and then I can derive debug on this, and the query mapper essentially would basically do the same thing that a query would support. So let's look at what the query supports. So so my idea is that if we, as long as this gets auto generated, I can essentially just do a movie query fetch, give it access to a pool, and then it should give me back this result without me writing it. So that way I can iterate on SQL without having to keep the SQL and my struct in sync, right? So, and this is not new. There's been a couple of libraries in other languages which do this. The one that I liked the most was this thing called JDBI when I used to work with Java. So this was I don't know if it's still the same. It's been a while since I worked on it, but this is the Fluent API. Okay, this is okay. Let me look at, yeah, pretty much this, right? So it kind of figure out what it is. So here it does this query, but then you need to kind of like map the user.class, but it will not generate the user.class. I think you have to write the user.class here. But the idea is that this would essentially implement the DAO for you. Since then, I think they have been moving on to a Fluent API sort of things where you do a JDBI this thing, and then it'll handle this, and it'll create the type here. Oh, sorry, I don't suppose it creates a type, does it? Yeah, I don't know if it creates a type. Maybe I should. That's something that I need to look into. Figure out. It's been a while since I used this. Yeah, I don't suppose it will create a type. You need to create the type actually, right? So you need to create the user class or if you're using Kotlin, sort of like a sealed class or a data class there, and then it'll do that for you, I suppose. But that said, we are using Rust, and most of my ideas are kind of like inspired from some of these libraries that I've used in other languages. So yeah, you can take that with a grain of salt when I look at these things. That said, I do have to mention a couple of good libraries. There's this thing called SQL, so CQL.org. So CQL.org is like an open source org, and they have a bunch of interesting projects. So they have CQuery, which offers like a drizzle-like syntax for this thing, right? So they have like query select, and then it says from something, and then you have this column and where and all this stuff, sort of thing. And then they have this query builder. So once you give a query builder like Git, it's actually going to return a query, and then you just execute the query. Um, the reason I don't like, I mean, if you want to do this, you can always do this. The reason is that I feel it exposes pretty much whole of the database to the API surface layer. That's not what I wanted to do. And again, if you want to do, you know, uh, a little more advanced things like I want to do like with recursive sort of queries, or I want to do common table expressions, or if I want to do windowing functions and things like that, all that becomes very difficult in these kind of use cases. Or if I have some weird like extensions that I want to install to my Postgres database, like a PG vector kind of extension, then all that becomes pretty difficult to specify as a part of this. And this library has to keep up with it, right? I mean, that's the point of the object relational mismatch, right? But where we want the interface to be is exactly when the data is going to get serialized to our language, and not at the level that where the entire query or entire this thing needs to be there. But that said, there is also the CORM, which is kind of like an ORM layer on Rust. So you can see it kind of like do the derived entity model, and then you can give it this thing, and that actually creates this, and then you can also set up like one-to-many relationships and all that. I like this even less than CQL, but again, to each their own, I suppose. And then they also have this thing called cGraphy, which is essentially like a GraphQL client for this thing. So I think let's look at the cGraphy. Yeah, so it's like pretty much builds a GraphQL schema on top of CORM, and it uses async GraphQL. So so all these three are like equally valid approaches if you integrating with Postgres. But again, mine is just another set of opinions from what these libraries implement. That is all. So that said, so let's look at how this works, how this query as macro will work, and let's try to understand how SQLX itself works, and then we'll go from there. So one of my favorite things that I like to do is just pull down the source code and kind of play with it. So I did already pull down SQLX's source code. I mean, I've been using SQLX for a while. Let me just make sure that I have the latest. All right, so let's pull this. Come on. Pull. Make sure. Yeah. So let's look at what the query as method is. So let's kind of go to the doc first, and then go from there. So let's go to docs.rs. And we are basically looking at the query as macro, right? So we are basically looking at this query as macro. And the query as macro is there, and it does not use from row. Yeah, I wanted to also talk about this from row because that's another implementation option here. So I'm just going to comment these out. So here, instead of doing this, so we can do a from row. So this from row function. So again, you see it kind of derives this. So if you don't want to use the query part of it, you can use query as in this case, and then you can do a movie in this case. So right, this doesn't use I think it's right. So here this is equivalent, so we can run this and see that it's the same. So it basically returns the same result. It's still Arial, and then it's like 1988 somewhere. So it's the same result, but here in this case, it doesn't use the macro. I mean, I wouldn't say it doesn't use the macro. It's just that right now it's not using. It doesn't connect to the database at the compile time, right? But it uses a macro here. So let's expand this and see what this generates. So what this generates is that any struct that implements a from row would essentially implement a from row method. And this basically takes in a row, which is actually something that implements SQLX row. In this case, it'll be a Postgres row, PG row. And then it tries to get all these. So earlier it used to do this try unchecked get of something. Here it's basically going to get a try get of these rows, and then it's going to cast them to that type, and then it's basically going to construct the type and return it. So again, nothing magic going on. It's just that these are kind of like two approaches that SQLX gives to basically say, hey, do you want this query checking to happen at compile time, or do you want to happen, or you just will take care of it during runtime? So I prefer doing this at compile time because it gives us a lot of options on what these queries can do, and it kind of allows us to do this. But if you're anyway handwriting all these structs and doing all this, it doesn't give a lot. So, yeah, that's where things are. But now let's now talk about, okay, how do you do this? So I showed both these approaches that are there. So let's figure out how this query as works. So it says it doesn't use the from row, and we saw that. It uses, so let's look at the source for this. And then we can kind of like figure out which file it is, and then like view that in NeoVim. That would be better. So this is in SQLX macros mod rs. So let's do that. SQLX macros mod rs. Nice. That is so weird. Oh yeah, I think this gets. So wait, what version am I on? 0.7.3, and this is on head, I guess. So let's see. So cargo toml. Just to make sure I'm on the right version. Yeah, this is 0.7.3 and then head. These are the that are there, and the cargo toml here basically calls it SQLX macros is the package, but when it publishes it, it actually publishes it as that's interesting. Okay. So this is probably within SRC. Oh yeah. Oh, here. Okay, I was just looking at the wrong place. For a moment, I got confused. Okay, this is where it is. So essentially, so this basically just calls is for migrate, but we can look for query as. Yeah. So yeah, query as. So query as basically calls SQL macros expand query to do this. You need the database URL for doing this and all the stuff. So let's go to expand query. And the only thing that is there, so if you have args that are passed in, basically args get passed in here. Otherwise, it's just expand query. So let's look at this. Not sure why. Oh, that's probably because database URL needs to be set. Equals postgres slash dp. Let's restart. Not get that. I'm not sure why still complaints. Let's see if I can. And then let's do a. Let me go to the thing here. Oh, yes. Okay. Yeah, this is so weird. Maybe it's some test that is failing. Why is it looking for to-dos? Anyway, but we get the idea where it is. So essentially, it's in SQLX macro score, src, and then this is essentially where the expand query is. And if you see, this is a proc macro. So it basically takes the input stream, it parses the macro input as query colon query macro input. Okay, query is in, yeah, it's in SQLX macro score. So it has this, so it gets the SQL this thing. So it should have impl of parse on this. Okay, so it basically gets the query source, it gets the args, it gets the record type. Wait, but this shouldn't. So this, how does it? It is input as. So the token stream is there, so it should have a from. It doesn't have an impl of from. Let's look at the structure of the file. It's down here. So the structure of the file is like this. Query macro import, query parse, impl, query source. That's interesting how it gets. I don't know how it allows you to just do a type as. Yeah, I need to probably figure that out. Okay, so maybe it has impelled it here somewhere. Impl query data source. Because I'm wondering, how does the token stream get implemented for this input? Maybe wrong. Let's see. Not here. Let's see. Okay, maybe it derives the type. Okay. Yeah. Let's get to this. Maybe there's something that I'm missing here. So we'll see this. So it somehow gets typecast to query macro type, query macro input from token stream. And this token stream is from and token stream is just a normal Rust token stream. It's just the proc macro token stream that we get here, and then it then expands the input based on that. So we'll assume that from somehow okay, syn parse macro input. Okay, this is the syn crate, so it basically gives us the AST from there, and yeah, this is the bit that absolutely kind of like queries RC. I think it's because of impl. Yeah. So yeah. So this basically gives a syn result self that's here. So I think the parse is the thing. So as long as something implements parse, then it kind of does this. So because this is the one which actually sets the values for these here. So I think it should say yeah, this is the one which actually sets the SRC and then the span and the record type and all the stuff. So yeah, I think this is the one which actually does this. So let's look at the record type. Type is record type generated. Okay, we'll get to more of this. There's a lot more to debug here. And then, okay, so that's how this works. So, okay, that's at least one level of things that we figured it out. So this is coming from there. So, and then we do an expand input on this. And on the expand input, we actually take the live data source. So there are two data sources. One is the metadata data source and the live data source. So this is, so if it's offline is false and there does exist some database URL, then it does, and it returns this query source. And then let's see what it does with the query source. So then we have this, we match the data source, and if that's there, then it tries to get it from cached. And okay, so it does this expand input. So if it is there, or driver and drivers, data source, match data source. This is what we want. If it is matching, then finds this is found cache for the database, but no matching. That's for now. Okay. So it does get the data source. Okay, it does the expand input, and then what does it do? So you can get in here, you do an expand input. Okay. So you have the query macro input. So you have the query source live. Okay. Okay, but this just gets the database URL. So that means that it doesn't get the input yet, actually. So once it gets the database, so it needs to pass in the input somewhere. Okay, this is the data query. Where is this data coming from? Oh, here. Okay, driver.expand input. Okay, if for each driver, okay, if once it matches a driver, then it just returns it does a driver.expand on this. So this is in drivers. So expand input has a bunch of drivers. Okay, okay, let's look at that. So here in lib.rs, expand input has force drivers. Okay, let's look at force drivers. The force drivers has query driver for each one of the type that's there. So this is essentially what we want. And it has an expand method on it. So this expand method basically takes a function and then returns a type. Okay. So when you, wait, I'm a little confused. Okay. Now, it's okay. So it has this expand input method here for each one of those drivers. Okay, this is what we were looking at actually. So so it says driver.expand. Let's look at the function for this. So this is a function. So how does this get generated? So in the force drivers, then maybe this should get created. So let's look at the force drivers. Where did the force drivers go? Okay, hold on. Force drivers are here, and where are they? Okay, it's in lib. Okay, so query driver new. Okay, if you when the new method got expand basically gets called with expand with. Okay, so expand with basically then gets an input, and the way this works is that it does a describe blocking on the DB. So DB is query data of DB. Not query data, it's just Postgres. So DB is just Postgres. Correct? Yeah, no, it's something that implements database ext. Now database ext is a trait and that has describe blocking. Okay, so that means that if you find all the implementers of this, so let's find out who impels database ext. Okay, wait. Impel. Okay, so this is basically for query data. So it does it for query data. So this should implement describe blocking. So this is in data. Okay. So let's look at. Describe. Wait. So is there an implementation for this? No, describe blocking. There is no implementation for this. Okay, let's look at all the references for this. Okay, there is a describe blocking here, and okay, let describe. Okay. So let's look at AG. So now this is hidden. Where though? So this is in SQLite. Describe. Okay. Wouldn't this be? So database ext. Okay, let's see. Maybe I'm missing something here. So for okay, we'll go back to the mod here. Oh, sorry, here. So this is force driver. So we have the query driver new, and we have expand width of DB. So expand width is a method that basically takes the database, something that implements database ext. And if it is there, then it actually does a describe blocking. So it says DB of describe blocking. Now DB describe blocking. So I have to find all the implementers for this. So that means that should be in the macros. It's that. Oh yeah, this actually impels database ext and get feature gate. and it says impl describe blocking of this database. And impl describe blocking, I mean, this is again macros over macros over macros. So this good. Okay, this is getting complicated to debug. Okay, so here this basically takes caching describe blocking of new, and then it does a describe. So let's look at caching describe blocking. Okay, so we have the class, this thing which has the this thing, and this describe. Oh, it basically just does a block on. That's because this is an async connection, so it just does a create dot block on. And I think this is just yeah, this is just whether you use Tokyo or if it uses STD, async STD, it's going to use a different runtime. Okay, and then it tries to get a connection, and then on the connection, and then on the connection it just does a describe. So essentially that's what it does. It does a describe on the connection, and then this works. So this describe, again, this is the doc hidden. So describe SQL and parameters. This is used by compile time verification for query macros. Power them in. Okay, perfect. I should probably have started with this, but then we wouldn't have been able to find it in the doc. So anyway, so here this actually has a describe block, which has a list of columns and then a list of parameters that it needs, and it has a vec of options. So, and it has a nullable, right? Which is cool. So let's try working with this. I think this is a good enough starting point for me to do this. So let's look at this. So it said yeah, doc is hidden, but then so this is on executor. So this is on any executor actually. So I should be able to do this on the pool then. I should be able to come here. So pool implements executor. So pool transaction connections, they all implement executor. So so if I have this query, so I'm going to take this query and I'm going to refactor it. Okay, so I'm going to say ta let query equals, and I'm just going to call. So let's get rid of this. Now we're going to say pool describe, a pool dot describe. I don't know if this is going to work, but let's see. Let's equals. Information is available. No method describe found for struct pool. Can I do this on the ref? No. Let me do this. Let con equals pool dot acquire dot wait. Wrap. Okay. So once I get this, con dot. I mean, you may not be able to find this here. Not found for struct pool connection Postgres. Why? You know why? I think if I let me do the previous one itself. So I think the problem might be because we did not include executor in scope. Yeah, this works. So it's there. So I am fairly certain that executor is implemented by this. So and the way you can check this is if you go to SQLX and look at executor. SQLX executor. Sorry. So you can find all the implementers, right? So if you go to implementers, you can say hey, all of these guys are implementing, and this pool actually implements executor as well. So that's how I know done this, because I've done this for the transaction as well. So even transaction kind of like implements executor. So if you go to a transaction here, yeah, that's a good question. Why does it not say that? So if you go to a pool and then you do a pool.begin there, you can begin returns a transaction, and I know the transaction this should implement executor. Um, I think one of those. No, I think transactions deref implements. Yeah, transactions deref implements. It does this where it actually returns. Um, uh, yeah, there was this one case where for a transaction, if you do this thing, so it actually returns. Um, so if you do an and deref mute on the transaction, it actually gives you the connection underlying that, and then you can do things with the connection actually. So yeah, it gives you a target. So all SQLX things actually have a target, and the deref on the target essentially will give you this thing. So yeah, this is for another stream, I suppose, but usually the PG transaction or whatever implements a connection on this. So usually you'll have a target on this, and then the target would get you the connection. So that's that. We'll talk about it. So this gets us the described result. So let's find out if we can iterate over it and figure out what the types of these are and see what we can get there. So we'll say for start columns exist. See, this is why Copilot is absolutely. So you have columns that are there, and then you can check whether nullable is there. So let's try doing this. So let's do rest.columns.iter .enumerate, because I also want the this thing. So we'll say for I comma call, right? So there we'll say println bang column call.name dot, and then we'll say rest.nullable nullable is a method actually. Is it a field? Oh, it's a vec. So I can do a rest.nullable of view size. So it says, so I should be able to give an I on it. And since we know we are going with this, I think we can safely do an unwrap here. Is null. Should be there, and then we'd also want to get its type information. So rest dot column. or we got the call actually. So call dot, I don't see any type information here. Maybe I think this is again, let's see if I can get column interface. Yeah, this gets us the ordinal and type info. So we'll get the type info here. Again, this might be one of the reasons where tie dot. Okay, tie has OID and kind. Let me also get type info here because I'm. So you have name as type info, okay? So let's look at that. Type info here. My name. And then do the nullable. That's good, no? Yeah, just that I can do inline expressions. Okay, just deal with this. Okay, let's see. So this should work. So let's see. What's the? Maybe that was the reason why this is the problem. Yeah, I thought we fed expressions in Rust. If is an expression. Yeah, if it's supposed to be an expression. So I should be able to do if. Oh yeah, I just needed like curly braces around it. Cool. I was like going crazy for a bit. So now let's do a cargo run. Just to figure out, okay, what comes up. All right, so we get a date, not null, we get a text, and we get a date. So obviously we need to figure out how do you map these onto the other types. So we can look back at SQLX code to figure out what this gives. So, but this is a good starting point. This is a good starting point for this. So we can figure that out. It's just over an hour in the stream. Maybe we should wrap up. This is like a good logical point to stop. Let's see. We were at we were at the we had quite a bit of an excursion, didn't we, into this code base. All right, so we were looking on the expand with, right? So SQLX macro score, common was it? Maybe we can just go from so here we had the expand with. Expand with basically had this data. So okay, this is basically where the query data comes after we do this, and then we do an expand with the data, and this is essentially where the thing happens. So we try to find the number of parameters. So we are not dealing with the parameters here. So we're looking at the output of this thing. We get the columns, and so this is the one which actually generates the code for the query path. And then this is basically where it does the mapping. It does the columns to Rust of the DB. Column to Rust here, and tries to parse this, tries to find out if it's nullable, like how we were trying to find that. And then and then it tries to find out if it's nullable or not. And how does it know that this is the type it needs? Okay, here this is the column type. Okay, match type command nullable, column type dot exact type dot two tokens. So this essentially takes a type that we pass it, and then it just does the two token stream here. So now let's look at this column type. Oh, this is the column type override that it has, and then it gets this column type. Okay, this is the type here. So this type, wow, this is really, where is this type coming from? Here. Okay, so here it does this decal override, and then it takes the column type override, and this declaration is basically parsing the column name. Let's look at column decal. Column decal. It's called name.find. Yeah, this just tries to find the reminder. Find the identifier, because if you want to use surround logic to parse it, if you try to feed this into synparser, you get an ungreat error or some kinds of invalid identifiers. So it tries to find the identifier and then looks for like colon or bang or something. Then it does the parse ident of a reminder, otherwise it gives a parse ident of a call name. then it gives the remainder as a string, and then it tries to find the parser. Sorry. So if remainder is not empty, if the remainder is empty, then it basically gives a column type override of none. This is so confusing. Okay, what happens then? If the column type is none, then checks. Oh, this is a nullability override, but does not talk about. Doesn't talk about the type. But I'm wondering if should we even care about this type, because we can. Oh yeah, so this gets the column type for the DB. It gets a type info, and it gets the return type for ID. Okay, that's interesting. Okay, this is from database ext. It's so cool. So we get the return type for ID from database ext. This we know, we already saw. So this is implemented as a bunch of macros here. That's about it. So for each one of these types, so it basically comes here. So for each one of these types, it actually has. Wait, I need to figure out how this works. Okay, so impl database ext. So for a bunch of like database paths for different types, and then you have the param checking, feature types, row, and describe blocking path. So what does it do? It actually implements database ext, and then this is for each one of them, I suppose, right? Yeah, so this is for star dot. Then it's a param type for it, and then this also does a return type of ID. So here, this is interesting. So it actually does this, the type info, and then it matches. This is doing it for each type actually. So given a type info, it is going to return you a token stream type for this thing. And the way it does this is basically loops through, and it tries to find out whichever is the first match of that type. It basically stringifies this. I really need to figure out how this database ext for Postgres works. So the impl database ext. Let's look at this. So again, so impl database ext. So this is right there in database. Okay. So feature MySQL. Okay. Impl create database ext for database. Okay. So now if is database ext a pub create? Yes, it's a pub create. That's nice. So I should be able to get this trait for Postgres and check what happens. Okay, let's try doing that. So let me try getting database ext here. So which is the namespace in which this is exposed. So this is in SQL macros core, but this is probably not exposed in the, not intended to be used directly. So let's find out if can I get SQL macros core in docs.rs. So let's see. It's here. Yeah, I think I can add this type because I don't suppose it's going to get exposed outside. Um, let's look at the cargo.toml here and see if this needs to be exposed. It needs to be exposed by it only does the pub use SQLX core. If I have the feature macros, pub extern create SQLX macros, but it doesn't. It only exposes the from row and type, and then so here again, so it uses everything, but it doesn't pub use anything here. So I probably need to import it manually. So let's add that. Let's see. So none of the features are enabled. I need to enable Postgres and SQLX Pro. Postgres, I suppose. Let me just enable Postgres, see if I can get away with that. Again, this is all exploration, right? So let's try to get the database ext. That is interesting. So SQLX macro score zip.rs, pub mod query, blah, 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 pub mod migrate. Mod database is not pub modded. So we can't get to our database ext, even though it's a pub trait from within this thing package, but the crate doesn't expose it, so we can't get to it. Why, oh why, oh why? Would be useful for others where we don't have to do this. I mean, I guess we can re-implement this in a sort of a simplified form, because all it does is it basically implements this, like for example, impl database ext, and in impl database ext, it does this return type for id, and all it does is that if the type info matches some info here, or it does is compatible, it basically calls the compatible function, and then it returns that. Yeah, it first checks for type info. If it has type info, then it returns that, and then for each one of them, if type info doesn't if it doesn't directly match type info, then it does this. Otherwise, so let's try to find out SQLX core types of type database. Okay, so this should be in Postgres types. So let's look at this. Say let's look for text actually. So that should be there. So this should be SQLX type of Postgres for text of D. It should also work for string. Okay, let's do this for string. I think this would be easier. So it does it for copy on write strings. It does box strings for strings, all this. And it gets a type info. So if it gets the type info, and this type info is basically Um, is it for ampersand stir? So it just basically returns PG type info text. So if PG type info text math does it works. Otherwise, it tries to call the compatible and tries to find out, hey, is this compatible with this PG type info? And then it returns. Basically, it just goes through a whole bunch of match statements to do that. And essentially, as long as, since this is exposed to the outside world, I suppose. So I think you can do. Wait, yeah, that's a good point. I think it should be exposed. So I should be able to do use SQLX, um, Postgres types of okay, this is so these um, I'm looking at, okay, maybe I'm looking at it wrong. Hold on one second. So type. Oh, this is just implementing type for stir. Oh, these are normal string types, unless I am doing this. So this, I mean, these are Rust types, right? So I can, since I am dealing with Postgres database, I can actually call this method and do this. So let's do it for just these three types, actually. So if I have to follow the same logic that they wrote, then I probably have to do something like I have to return. Oh, I have to start returning the type. Okay, maybe I have to get to the proc macro bit before I get to this, but I think this is a good point to sort of like stop the stream and pick it up in the next stream. So in the next stream, we'll try to get the actual proc macro definition in there, and then try to do that. So this is first part of the stream. Yeah. So I was a little ambitious to think that we can get to the proc macro in the first stream, but this is a pretty good starting point. Yeah. Let's deal with it later. Okay. All right. So I'm see you folks. Thanks. Bye.